Hello, welcome back. So in this lesson, we're going to see how to perform convolution using the signals module in the SciPy library. So after we do this, then in the next lesson, we shall develop our own convolution algorithm. So what I'm going to do is I'm going to create a new script by coming over here and using the save as function. And I'm going to save this as number one underscore convolution. Underscore version 1 v1 like this, and then we can clean all of this. Let's just start from the beginning. Yeah, so as usual, we start by importing our signals here. So import my signals as 6, right? And then we need matplotlib, definitely. So from matplotlib we need a pyplot. From matplotlib import pyplots as plt like this. Once this is done, we need to import style for ggplot. So we can say from matplotlib import style, and then we need to import signal, the signal module from SciPy. So we say from SciPy import signal like this. Once that is done, we can perform convolution with a single line. We can create a list to hold the result. So we can say output signal, this is going to contain the result, output underscore signal equals signal, and when I say signal, I'm referring to this signal module here from SciPy, signal.convolve, because the convolution function exists in the signal module. That's why we have to say signal.convolve like this. All we need to do is pass the two signals we want to convolve and set the mode. And we want to convolve 6 dot input signal 1 kilohertz underscore 15 kilohertz. We want to convolve this with 6 dot impulse underscore response. And we can set a mode to same. Later on, we shall explore different modes of convolution, but now we can just set the mode over here. There's a third argument known as the mode, which we can set over here to same. And once this is done, we've performed our convolution. Now, what we have to do is simply plot the result. So we can start by ggplot style.use ggplot like this, and then f comma plt underscore array equals plt.subplot, and what we need is 3 subplots, and they all share the x-axis. So we say share x equals true like this, equals capital T true like this. And then once that's done, we can set a super title, f.subtitle, and the super title here we can give the name convolution, and then we can say plt underscore arr index 0 dot plot. And what we want to do is want to plot the input signal first, so we can say 6 dot input signal 1 kilohertz 15 kilohertz, and we can add a color. Let's say comma color equals, we can add, let's use cyan, how about that? And then we can give it a title too, so we can say plt underscore arr index 0 dot set underscore title, and the title here we can say input signal, and then we can plot the second one. To reduce the typing noise, I'm just going to copy and paste this 3 times to rename. The second one here becomes index number 1, index number 1, and this signal here becomes 6 dot impulse response impulse underscore response. We can set the color here to, let's set the impulse response to pink, and the title here is of course impulse response. And then the last one here, number 3, we can set this to output signal here. And then the color, we can use a different color here. How about we use magenta like this? And then we set a title to output signal like this. So right, looks like we set. This one here has to be index number 2, sorry about that. 2 here, 2 here, because we have 3 subplots, 0, 1, 2, we have 3 of them. Once that is done, we can say plt.show to plot it. plt.show like this. And then we click here to run the module, and then OK. And this is what we have. So this is it. Perhaps cyan was a bad choice of color, but you still get a picture, don't you? So this is the input signal. It's characterized by high frequency 15 kHz component and a 1 kHz signal. And then we've got this impulse response, which is designed to be a low pass filter with a cutoff frequency of 6 kHz. So we convolve these two signals, and what we get is this output signal. And as you can see, this represents just the 1 Hz or just the 1 kHz component in the input signal. So that's all there is for this lesson. If you have any questions at all, send me a message or leave it in the questions area. And if you are enjoying this lesson, please take some time off to leave a review. In the next lesson, we shall see how to design our own convolution algorithm from scratch. So I'll see you in the next lesson.